Hey guys, this is 11.2. This is the second sign chart problem. There was a I wrote down the wrong number, so this -1, -4 is supposed to be way down here, not up here. My bad. Okay, so we saw that from the first derivative all the way up to 0. Our line should be increasing, going up. So all the way up to this x value of 0, our line's going up. Then from 0 to 2, we see that the sign chart also has a plus, so we're going up from 0 to 2. Then from 2 to 6, we go down. Then from 6 and on, we go up. So this is the general shape of the graph. Now we're going to figure out whether these lines become curves up like this, or these lines become curved down like this. Okay, so that's what the second derivative is for. So it says plus, so that means concave up. Wherever there's a plus sign, so concave up, and wherever there's a negative, it's concave down. Okay, so we're gonna have up, down, up. So let's look back at how to draw this concavity. Concave up looks like this sucker, like a up parabola. But if you look at where we're concave up all the way to 0. Well, this doesn't look like a parabola. It just looks like a piece of it. So for this first portion all the way up to 0, we are increasing from the first derivative, and we're concave up. So let's look at increasing and concave up. Increasing, concave up. So my curve should look like meh, all the way up to the x value of 0. So I'm gonna make these two little dots look like this little curve. There we go. Okay. Now let's look at this next piece. It says concave down from 0 to 3. So from 0 to 3, we're concave down. So let's find where 3 is. 3 is right here, I think it was. And concave down looks like a upside down parabola. And I can make that whole upside down parabola concave down. So we make like a little parabola, look in there. Okay. Then it says from 3 all the way to the end, we're concave up again. And concave up looks like a whole parabola if you have all those points. So concave up, this next piece is going to look like a parabola. Woo! Okay, let's go again. This is a word problem. It says the revenue is this. In the word problem, we're only going to look at the x values from 0 to 90. And then it says, what's the local maximum and minimum? And is it concave up or concave down? Okay, well, either way, for local maximum and minimum, that's from 11.1. That's called extrema. So we have to find the first derivative, draw a number line, all of that. Okay, so let's find the first derivative. And I'm going to say it's r prime x because here we have the letter r of x instead of f of x. Okay, so the derivative of 1911x is just 1911. Then we take the 3 and we bring it down in front and multiply. And I think that gives you minus 0.39 x squared. Okay. And to find the local max and min, we have to take this first derivative and equal it to 0. So let's equal it to 0. We're going to have 1911 minus 0.39 x squared equals 0. Then we're going to get x by itself. I'm going to subtract this 1911. And we get negative 0.39 x squared equals 0 minus 1911. Negative 1911. Then that decimal on the x is multiplying. So to get rid of multiplying, the opposite is divide. So we're going to divide by negative 0.39. Divide by negative 0.39. Okay, and we get x squared equals, let's divide this stuff. 1911 divided by, negative 1911 divided by negative 0.39 is 4,900. Okay, but x is still not by itself. So now, to get x by itself, to get rid of a tiny 2, we're going to put a house. And the square root of 4,900 should be 70. So, to find the local max and local min, you have to take the first derivative, equal it to 0, we just did, put this 70, and then find numbers before and after and test them into the derivative. So a number to the left of 70 is 69, to the right is 71. And now we're going to plug these numbers into the derivative to figure out whether we draw an up or a down arrow. So we're going to put 69 into the derivative. Which is this sucker with the 0.39. Then we're going to put this 71 into the derivative. And I really just want to know whether this stuff is going to be positive or negative. I don't really care what the number is. And for this first sucker, I got positive 54.21. For the second sucker, I got negative 54.99. Good enough. Okay. So that means on this number line, for the 69, I have a plusative, so we go up. For the 71, I should be drawing a negative, so that's down. Okay, and then now we ask ourselves, do we have a maximum or minimum? Well, since this is at the top of a mountain, this is a maximum at an x value of 70. But I want to know the y value to come up with the whole point. So to come up with the y value of anything, you take this x value and you plug it into the original r of x. The original with this 1911x minus this 0.113, yeah, this one. So I'm going to take this 70 and plug it into the original. And this will give me the y value. Anytime you want a y value, you have to plug it into the original. And I get 480. Okay, so the question was, what is it? It just started raining in my office. Is it, the question was, is it a maximum or a minimum? Well, it's a maximum at the x value of 70, comma, the y value 480. Okay, now let's do concave up or down. For concave up or down, you have to come up with the second derivative. So let's find the second derivative. If this sucker was the first, the second is 1911 goes away, and this 2 comes down and multiplies. And I get negative 0.78x. Sorry, I had to put a trash can under the leak in my ceiling. Okay, now we're going to equal this to 0. and solve for x. Well, if I divide by negative 0.78, you're still going to get a 0. So we get x equals 0, and that's going to go on our number line. Now we're going to pick a number to the left and right and plug it in. So the steps are repetitive. It's just one you use with the first derivative, the other you use with the second derivative. Okay, let's pick a number to the left of 0, like -1, and a number to the right, 1. And then we're going to plug these in to whatever I got this 0 from, which is the second derivative. So we're going to say r prime of -1. And that gives me a positive 0.78, I think. Then we're going to do r prime of 1, and we get negative 0.78 times 1, which is negative 0.78. So we can say that where this -1 is, since it's positive, I'm going to draw an up arrow. Since where I plugged in this 1 comes out negative, I'm going to draw a down arrow. And then that's going to be my concave up and concave down intervals. My concave up is from negative infinity all the way up to 0. And my concave down is from 0 all the way to the right. So 0 to infinity. Woohoo, done with that problem. Okay, let's look at this next sucker. It's kind of tricky because it doesn't give us the revenue, but part A asks for the local min and max of the revenue. So this is not the revenue. This is just little p. If we look on this last problem, they said that the r of x, the revenue, was x times p. So that's what we're going to do. To find our revenue, r of x, it's equal to x times p, or x times this sucker, p, 15e to the negative x. So this is our revenue. Now we need to take the derivative, first derivative, so I can find the local max min. So let's take the first derivative. We have to use the product rule that says something about the first and the second. Do you remember the formula? The product rule says first times the derivative of the second. So first is x times the derivative of the second. Well, the derivative of anything with an e is the exact same e thing, but you have to multiply by what's the derivative of the air. So the product rule says first times the derivative of the second. So I wrote down my first term, x. My derivative of the second term is the exact same thing, but then I have to multiply by the derivative of what's in the air, which is -1. So this first term is x, and then this 15e to the negative x times -1, that's all for the derivative of this second term. Okay, then plus the second term times the derivative of the first, x, which is just 1. Okay, now let's clean it up. This x times -1 in this first section is just negative x times 15e to the negative x. Then I think I'm going to go ahead and write this second sucker as 15e to the negative x times 1. Just trust me. Okay, so to find the local max and local min, we're supposed to find the first derivative. We did. Now we have to equal it to 0 and solve for x. Well, if I want to equal it to 0 and solve for x, there's an issue. There's 15e to the x on both of these suckers. What we're going to do is we're going to say that 15e to the negative x is a GCF. As in, we're going to take it out from both of these. So we're going to have 15e to the negative x. And then if I take that away from this first term, all I have left is a negative x inside. If I take away that GCF, away from this second chunk after the plus sign, all I have left is a plus sign and a number 1. And we are supposed to be putting these equal to 0. So I'm gonna have 15e to the negative x equals 0 and negative x plus 1 equals 0. Okay, and then I'm just gonna tell you right now, anytime you have e to the x, it gets crossed out. So we don't know how to solve for e to the x yet. So go ahead and just cross it out. Okay, then let's solve this sucker over here on the right for x. So anytime we have e to the x, just cross it out. So it's kind of like that GCF just got trashed. It was real nice. Okay, so then on this other sucker, if I try and solve for x, we subtract 1. And we get negative x equals negative 1. Then divide by negative 1. And we get x equals positive 1. Okay, so this is probably going to be my local max or min. But we need to draw a number line and put it on there. So let's draw a number line. Here's my 1. I need to pick a number to the left and right. Like a 0 is to the left of 1. And to the right of 1 is 2. And now we're going to plug these into the derivative. Into this negative x times 15e to the, yeah, okay. So we're going to plug a 0 in. So let's go slow. We're going to have, instead of negative x, I'm going to put negative 0. Times 15. To get the e, we press second, ln. Then in the error, it says negative x. So I'm going to type negative, and what am I plugging in? Oh, right, a 0. Then get down on the same line, plus sign, 15, get your e back, second ln. Up in the air, type negative, what are we plugging in? X, oh, 0, we're plugging in 0. Then come back down on the same line, times 1. And I got 0. That didn't help me much. Let's try maybe 0.5. I just want to see if it comes out positive or negative. So let's try maybe 0.5 instead of the number 0. So wherever I'm putting that 0, I'm going to put 0.5. And when I do that, I get a positive number. So we go up there. Then now let me try plugging in 2. Now I got negative number. So that means we go down. So here at the top of this mountain, we have a max. So we for sure have a max at this x value 1 comma something. And remember, to find the y value of anything, you take this x value 1 and you plug it back into the original. So let's take this 1 and plug it back into the original. Not the original p equation, but the original r equation. So we're not taking this 1 and plugging it back into this p sucker. We're plugging it back into this revenue. This x times 15 e to the negative x. So instead of x, I'm going to put 1, because we're plugging in 1, times 15 second ln. And then in the air, instead of negative x, I'm going to put negative 1. And I get 5.5. Yeah, okay. So I'll just round it to 5.5. Okay, so we have a maximum. I think in your homework, they don't even make you find the point. You just have to say maximum. Okay, now we're going to find concave up and concave down. Okay, well, I think that's a trick. If I try and find concave up and concave down, this was my first derivative before I took out the GCF. This was my first derivative, okay, before I took out the GCF. But if I take the derivative again, let's see. If I take the derivative negative x times 15e to the negative x, I'm probably going to get the same thing, exact same thing, but we can do the work. Okay, so the product rule says first times the derivative of the second. So we're coming up with the second derivative. The first is negative x times the derivative of the second is the exact same thing, but you have to take the derivative of the air, which is a negative 1. So all I did is I'm taking the derivative again, and I did the first times the derivative of the second plus this same second. So we're not even ready for this 15e to the negative x times 1. We're not even looking at that. We're just doing the product rule on this first chunk of goodies. So we did the first times the derivative of the second. Now we have plus the second 15e to the negative x times the derivative of the first, negative 1. Okay, and this then, so these two suckers are just for this first chunk. I did first times the derivative of the second plus the second times the derivative of the first. Okay, and that's just for this part right here. Now let's take the derivative of this chunk. 15e to the x times 1. Well, times 1 doesn't mean anything. It doesn't change anything. So 15e to the x is, let's just take the derivative of it, plus 15e to the negative x times another negative 1. Okay, now we're going to take the GCF again, because if you look, there's a 15e to the negative x between every plus sign. So let's take out the GCF of 15e to the negative x and see what we get. So r double prime, we're going to take out that 15e to the negative x and see what we got left over. Well, if I take it away from this before the plus sign, I have negative x and a negative 1. Those two suckers multiply. Negative x times negative 1. That's just 1x or x. Then over here, if I take out 15e to the negative x, I just have minus 1. And then again, another minus 1. Okay, so that makes a big fat minus 2. So that's r double prime. Okay, the whole point of what we're doing is we're trying to come up with concave up and concave down. I mean, concave up and concave down. So we took our first derivative, did all that stuff, took our second derivative. Now we have to take this second derivative and equal it to 0. And we're just going to take each little chunk and write equals 0. Well, I think I told you like 10 minutes ago that anytime you have an e and you try and equal it to 0, it gets trashed, because we don't know how to solve it yet. But over here on this right, this x minus 2, we know how to solve that. You just add 2. And that's the number that I put on my number line. So for the first and second derivative, you do a number line. You equal it to 0. You do all the same process. It's just about where you plug in your numbers that's different. Well, the number to the left of this 2 is 1. The number to the right is 3. So now we're going to plug these into the second derivative, which is this 15e to the negative x times x minus 2. So we're going to plug in a 1 into both of these x's, then we're going to plug a 3 into both those x's and see whether we get a plus or a minus. So 15 e to the, let's see, negative 1. I think I typed that wrong, negative 1. Because we're typing 15 e negative, then whatever x value I'm plugging in, 1. Then I'm going to do open parentheses, 1 minus 2. Hey, and I got negative. So that means down. Now let me plug in 3. Ooh, and I got positive. So that means up. And then right there, we can tell our concave up and concave down. So our concave down is this left-hand piece. It looks like from negative infinity all the way up to 2. Okay, but then it's concave up from 2 to infinity. But in this word problem, they gave us some restrictions. In this word problem at the very beginning, they said the only x's we look at are from 0 to 5. So that means instead of putting plusative infinity on the concave up, I'm just going to say 2 to 5. Because we're not supposed to go past 5. Then on the concave down, instead of saying negative infinity to 2, I'm going to replace that negative infinity with the number on the left of the alligator, 0, because we're not supposed to go past 0. We're only supposed to be in between 0 and 5. So we're concave down from 0 to 2, and then we're concave up from 2 to 5. And the easiest way to do that is to take those infinities that we had at first and change them with the numbers from your restrictions, 0 and 5, 0 and 5. Yay!